All right, so now the fun kind of interest. Rather than talking about all the interest you're earning from savings, we're talking about loans and credit cards and mortgages and interest that you are going to have to pay someone else. One of my favorite teaching memories is teaching seventh graders about credit cards and what it means to have to pay interest, because there's always one person in the class that is absolutely livid and think it is so unfair that you put money on a credit card and then you have to pay extra money back, that you don't just have to pay the money that you borrowed on the card. And every year when I would teach it, there was always one that was really upset. In fact, a couple of them are sophomores right now that threw a really big fit about it. But that's the truth of it. Is you borrow money, the person or the company or whoever you borrowed money from wants their money back, but they want interest as well. They want that extra amount because they let you use their money for a while and it kept them from being able to use their money. So for any loan, we're not going to get into a lot of the details of loans. You'll spend weeks discussing this stuff with Mr. Thorley, and we'll spend some in-time class on it. But we're going to mostly cover the math in the video and try and keep it a little bit shorter than the last one. So the principal amount is how much money you borrowed. The loan term is the amount of time that you have to pay that loan back. All right. So you get a formula. Now, a lot of loans, most loans are what we call installment loans, meaning that that's a terrible color. An installment loan means that your payment is the same every single month. Okay. Credit cards vary a little bit there, but your payment is the same every month until the loan is paid off. And this formula should look really familiar to one that we used with savings. The difference is you're not adding money to it every month. You're taking money off of it every month. So the formula is a little bit different. You've got to be careful with how you use it. But the representation's the same. PMT still stands for payment. Principal is still the starting amount or how much you borrowed. APR is your interest rate. That's your percent. N is your number of payments every year, and Y represents the years. So let's just jump right into an example. It says, suppose that you have a student loan totaling $7,500 when you graduate. The interest rate is 9%. The loan term is 10 years. What are your monthly payments? How much will you pay over the lifetime, and what's the total interest? So my payments, first of all, are going to equal, actually, let's go ahead and let's do that down here. Let's see if I can get this to still fit. So your payment is going to be that formula right there. So you take the principal amount, $7,500, and we're going to times that by our rate, which is 0.09, divided by the number of payments every year. We're going to make 12 payments. We pretty much assume that you make a payment every month. Okay, so this N is almost always going to be 12. And then on the bottom, we put a bracket, 1 minus parenthesis, 1 plus the APR, again, which is 0.09 over 12, and then raised to the negative N times Y. So negative 12, and we want to pay this in 10 years. So I'm going to do negative 12 times 10. Now notice the difference. Last time we did all this work and then we added 1. And this wasn't raised to a negative. And again, that's the difference between paying down a loan and earning interest each month. Okay, so if I plug this in my calculator, again, just like before, I'm going to go ahead and do the first couple as fractions. 7,500 times parenthesis 0.09 divided by 12, close my parenthesis, and then on the bottom, I'm going to put a bracket, 1 minus a parenthesis, 1 plus 0.09 divided by 12, raised to the negative 12 times 10, close my parenthesis, and then I need to close my bracket. All right, so when I hit enter, it tells me that my monthly payments are going to be $95 and we'll say 1 cent. We'll round that up to a penny. Okay, so we're gonna have to pay $95.01 each month. Then it says, how much are you going to pay over the lifetime? Well, this is how much I pay every month. So for 10 years, I've got to times it by 12 months every year times 10 years. So my payments are going to be for 120 months. The total amount I'm going to pay off is $11,400.82. Now, this is why my girls freaked out and thought it was so unfair. You only borrowed $7,500, and in 10 years, you're going to pay them back $11,000. They're going to get $4,000 extra dollars from you because you paid that in interest. Okay. Well, let's figure out exactly what that is. Let's minus the 7,500. I think that was part of the question. So you're going to pay $3,900.82 in interest. That's a lot of interest. And I know it's spread out over 10 years, but that's a lot of extra money that you could do other things with. Now, just like before, we can use our finance app and the TVM solver to solve these. Now, there's a couple of differences, okay? Your payments are the same. This is still your payments total, how many payments you're going to make. The interest, you don't divide this time. Don't divide by N. And what was the other one? Oh, down here, we need to change this to 12. Okay. Other than that, it's the same. This is how much we borrowed. And the final value, we want to pay our loan off. So we leave that 0, and then we're going to look for the payment. So for example, 12 monthly payments every year times 10 years, so 120 payments. But instead of putting 9% divided by 12, I'm going to just put 9. My principal value, I borrowed $7,500. My payments, what I'm looking for, just remember to change this down here to 12. Okay. So I go to payment, alpha solve, $95.01, just like we got here. Okay. So you can still use that, or you can do it by hand. It doesn't really matter to me. So here's something interesting. We're not going to take the time to do the math, but something I want you to understand about these installment loans. And it's especially going to stand out when we get to mortgages. So every month you are charged interest. So what this is saying is how much of your payment each month goes towards the principal that you owe and how much is going towards interest. So in the first month, you are charged $56.25 interest. You make a payment of $95. So 56 of that, $95, goes towards interest, which means 38 of that is what goes towards the principal. So the amount that you owe only goes down $38, even though you paid $95. So now instead of owing $7,500, you owe $7,461. So in the beginning, the amount going towards interest is going to be high because your loan amount is high. But as your principal goes down, as this amount goes smaller, your interest amount is going to go smaller, and the amount that you pay towards the principal gets bigger. So in the beginning, a high amount goes to interest, low to principal. And as time goes on, your interest decreases and the amount towards the principal increases as we go on. And I'll show you a graph here in a little bit of what that looks like. Maybe it'll be in class with an actual mortgage. Okay. Now, credit cards. Wow, talk about people getting into trouble financially. This right here is probably, other than medical, I would bet that this is the number one financial problem that people have when they have financial problems. So for example, and most of you are familiar enough with credit cards. In fact, some of you even have them. But a credit card, you basically swipe a card, you use someone else's money to buy something. You are charged interest rates, and they're usually extremely high. Look at this example. The interest rate is 21%. That's way more than what you're paying even on a student loan of 9%. So you have a really high interest rate, but they let you use their money to buy whatever you wanted to buy. And we're going to talk a lot more about credit cards in class. But just like anything else, you have to pay down the amount that you borrowed plus this high amount of interest. You're going to have to pay it down, okay? So let's say that you have this credit card. You owe $2,300. Your interest rate's 21%, and you want to pay it off over the next year. You want to get it paid off so you don't use it anymore, but you want to pay it down. So we're looking for how much do you need to pay each month to get this credit card paid off. So your principal is that $2,300. Your interest rate is that 0.21. N, the number of payments, you're going to make 12 payments in that year. Again, down here is all the same. The difference here is the year's only going to be 1. Your N is going to still be 12. Okay. So you can plug that in your calculator. So my payment is going to equal my principal times my 0.21 divided by 12, all divided by 1 minus 1 plus the APR. Whoops, I'm not writing the formula. We know the APR. 0.21 divided by 12, raised to the negative 12 times 1, and then we'll close our bracket. So doing that by hand, if we plug it in right here, again, I'm going to get my fraction. I'm not going to do all of these by hand because I don't want you to have to sit here and watch, but we'll at least do a couple of these. So we're going to divide by 12. On the bottom, we need a bracket, 1 minus my parenthesis, 1 plus 0.21 divided by 12. Close parenthesis. I'm going to raise that to the, I better be careful. I need 2 parentheses right there. I'm going to raise that to the negative 12. And then, can I close my bracket? I can close my bracket, but I better do it down here. Oops, what are we doing here? So my monthly payment, I think I messed up my, let's see. This needs to go away. We've got that in parentheses, that, okay, we're good. I had an extra parenthesis. So your monthly payment to pay this off would need to be $214.16. Again, in the real world, I would round that up to 0.17. In the math problem, it's going to probably have you round to the closest penny, even though technically this wouldn't pay it off because you're paying a little bit less than you're supposed to. So you would need to round that up. We can also use the finance app. So same thing, our number of payments, though, this time is just going to be 12. Our interest rate is 21%. That's absurd. We're trying to pay off $2,300. We're looking for the payment. So alpha, enter. So $214.17. You get the exact same answer, okay? All right. And here's where credit cards get you in trouble. And I really wanted to use this example because right now with all the COVID thing going on, there's a lot of people that owe money for credit cards, for mortgages, for student loans, for whatever. And the banks are saying, hey, don't worry about making payments for a while. We're going to keep charging you interest, but we'll put your payments on hold. Well, Paul is doing the same thing. So he's gotten into credit card trouble. He owes $9,500 and lost his job. So his company agrees to keep charging him 21%, but they're not going to have him make payments. So the question is, how much is he going to owe when he finds a job? So that's a YAR. In a year, he finds a job. So we want to know, well, in that year, how much did that $9,500 increase? So this isn't a payment question. This is because it's compounded daily. This is a compounded question of our interest. So the principal amount that we're starting with is $9,500. And my interest rate is 0.21. And that is compounded daily. Every day that's compounded. So up here, we need to put 365 compounds for 1 year. So in my calculator, this is going to be a lot of interest. $9,500, 9500, let's do this correctly. 1 plus 0.21 divided by 365 compounds. And that's going to be raised to the 365 times 1, which just stays 365. So that means in 1 year, now he's going to owe $11,719.23. He only owed $9,500 before. So look at how much that went up. That went up $2,219.23. So even though he didn't have to make any payments, now look at how much money he owes a year later. Okay. So credit cards can get you in trouble, and not making payments can really get you in trouble. Okay, mortgages. Again, not something that we're not going to talk a lot about mortgages themselves in the video. We're going to talk about the math. In class, we'll talk about mortgages a little bit more. But again, that's something you cover a lot with Thorley. So I mostly want to just deal with the math of a mortgage. Okay, so a mortgage is when you're borrowing money to buy a house. Okay. And a down payment is the amount of money that you pay up front towards the value of the home. Closing costs are kind of like fees that you have to pay the bank when you buy a house. Sometimes they have points involved, which usually work in your favor. The way a point works is a point is basically 1% of the loan. And if you pay up front, so like if you pay for 3 points up front when you take out the loan, you're paying 3% of the home. What that will usually do is reduce your interest rate. And the more points you pay up front, the lower your interest rate goes, pretty much. Okay, so a couple of examples here. Again, we'll talk more about mortgages, but the numbers get really absurd once we get into it. So this says that you need a loan of $100,000 to buy your new home. Now, in this day in St. George, Utah, you must be putting a really big down payment, because $100,000 to buy a home is not very much money to borrow. It's probably going to be more than that, but we'll go along for the sake of the question. The bank offers either a 30-year loan with an APR of 5% or a 15-year loan at 4.5%. Compare your monthly payments and your total loan cost under the two options. Okay, so it gives us all this information. Here is my loan amount. Here is my rate. N is I'm going to make monthly payments. The years is either going to be 15 or 30. So I could plug in all these numbers, but I don't want to spend the time on the video doing that. So we're going to go ahead and use our finance app. So my number of payments, let's do the 30-year first. Okay. So I'm going to pay for 30 years. I'm going to make a payment every month. And my interest rate is 5%. My principal value, again, that's how much I'm borrowing. I'm borrowing $100,000. Man, that sounds like a lot of money, doesn't it? My future value, I want to pay it down to 0. So what do my payments have to be? So if I hit alpha solve, that means that my payments are going to be $536.82-ish. Okay, so this is my 30-year. Now my 15-year, if I go up and I change this to, instead of paying for 30 years, if I only pay for 15 years, I'm going to make half as many payments. My interest rate's going to go down as well, but I still am borrowing the same amount of money. So let's look at what my payments do. My payments go up, and not as much as you think. If you're paying it off half the time, look at what my payments do, $764.99. They only went up like $200, but I only have to pay for 15 years. Now, here's what gets a little bit crazy. Total for 30 years, if I go back to my regular calculator here, I'm going to pay $536.82 every month of the year for 30 years. The total amount that I'm going to pay is $193,255. I'm not going to worry about the pennies. I'm paying $193,000 on a $100,000 loan. I'm paying twice as much as I borrowed. Okay. Now the 15-year loan, if I pay $764.99 every month, but I only pay it for 15 months or 15 years, excuse me, I'm only going to pay $137,698. So by paying $200 extra a month, look at how much money I'm saving. That's a huge amount of money. Yes, it's $200 more a month, but I mean, let's even look at that. Let's say it's a little bit more than 200, huh? It's 200. Let's say it's 230 more a month. So 230 times 12 times 15. So that's 41,000 extra dollars I'm paying. Not extra dollars. That's 41,000 that I'm paying in that 15 years than this person is paying. But total, look at how much my total payment goes down. I only pay 37% of what I borrowed. In this case, I'm paying 93% extra on what I borrowed. So 15-year loans, and Thorley's going to go over this a whole bunch with you, always make more sense as long as you can afford that monthly payment. If you can pay it off faster, look at how much difference in interest you're going to pay. That is a huge amount of money in the long term. Yes, it's more money every month, but in the long term, you're saving yourself a lot of money. And after 15 years, you're done. So if you're making this payment 15 years later, you're done. This person is still making that payment for 15 more years. All right. So now points. Here's where points come in. Now remember, 1 point equals 1% of your borrowing amount. Okay. 1 point is 1%, and you're paying it extra. This is not going towards what you borrowed. This is extra money that you pay. So if you wanted to borrow $120,000 on a mortgage, you have two options: a 30-year fixed rate with 4% interest, no closing costs, no points. That means upfront, you don't have to pay anything. All right. So let's look at what your payments are going to be. And again, I'm going to use the app. You are more than welcome to use the formula. I don't want the video to go on too long. So every month for 30 years, so 12 times 30, my interest rate would be 4%. I'm borrowing 120. Whoa. I am borrowing 120,000. 1, 2, 3. And I want to pay it all off. So my payment amount is going to be $572. So in this case, I'm going to pay $572, and let's round that up to 90 cents. Okay. Finally get to round up. I'm going to make that payment 360 times. So if I go back here, let's do 572.9 times 360, because that's how many payments I have to make. So total, it's going to cost me $206,244 to pay off my mortgage. All right. Choice 2 is a 30-year fixed rate, but my interest goes down to 3%. There's closing costs of $1,200 and 4 points. Wow, that's 4% that you're going to have to pay upfront. So first of all, let's deal with the mortgage. Let's go back to our app, to our finance solver. And we're still paying for 360 months, but now my interest rate is only 3%. I'm borrowing the same amount. So now my payments are going to drop to $505.92. So $505.92, and I've got to make those payments. I just want to see total what I'm going to pay for 360 months, right? So for this mortgage, I'm going to total pay $182,131. Whoa. I have all kinds of stuff getting made up. 182,131.20. So I'm paying a lot less. I'm paying what, $24,000 less than I was going to pay. So choice 2 is 24,000 less on the mortgage. But I had to pay all of this money up front. So I had to pay $1,200 plus I had to pay 4% of my $120,000. So $120,000 to figure out how much I'm paying in closing costs. 120,000 times 0.04 is 4,800. So 1,200 plus 4,800 is $6,000. So really, I'm not paying $24,000 less because up front I'm paying $6,000. So I'm only paying $18,000 less on my mortgage. Only $18,000. That's like a car that you could buy. So you're paying a lot less in the long run, right? You're paying $18,000 less, but up front, you would have to come up with $6,000 before you even borrowed the money. And that right there is where you need to decide. You would need to decide, because you're not doing this right now, but you would need to decide, is it worth spending $6,000 right now to save $18,000 over the next 30 years? And that might depend on a lot of things. Maybe you have a lot of money saved that you can put towards the closing costs. Maybe you don't have any savings and that $6,000 is not even an option. That's going to be a little bit different for everyone. What a lot of people look at is, okay, if I pay $6,000 up front and my payment goes down, how much did our payment go down? About $67. So if I divide the amount that I'm paying by the money I'm saving, that's going to take me 89 months. So that's going to take me almost 7.5 years before I break even. So for 7.5 years, this is the cheaper option. For 7.5 years, that's the cheaper option. But after 7.5 years, all of a sudden, choice 2 becomes the better option. So what a lot of people will do is they look at how long they plan on living in the house. If they don't plan on moving for a really, really long time, they might go with choice number 2. The other thing to consider is sometimes you can change your mortgage rate. You can refinance, change your rate, and that might change how much you're owing and paying every month. Okay. So homework went a little bit longer than I hoped, but it's stuff that needed to be said and taught. So I'm okay with that. What you are doing when you come to class, we will work on, this is homework 4D, I believe. We'll work on that in class. There's only like 7 problems, I think. It's not a very long homework assignment. You're welcome to try it at home. Do as much as you can. Make sure you have these formulas in your notes, and hopefully you've got a TI-84 on your phone, or you've bought one that you can use, because it'll go a long way to solving these kind of problems.